Hi everybody, in this video we'll work on a few improvements on my ESP-based sensor hub for Home Assistant, of which you can find the video in the description. I have used this device around the house for a few months now, and I have noticed a couple of problems. If you haven't seen the video, I suggest you take a quick look at it, but briefly, the core concept was to build an hub capable of reading meaningful information from the environment, as well as receiving user inputs to be integrated into Home Assistant with very powerful ESP Home. Briefly, this hub can read temperature, brightness, humidity, and it can also receive user inputs. The two main problems I have found using it are that it often struggles to detect reliably the human presence, and that it can be hard to see the buttons in a low light situation. To solve the first problem, I changed the technology employed for detective movement. In the old hub, I use a peer sensor. These are cheap sensors, about 1.5 euros each, but it struggles when trying to detect a small motion. For instance, I cannot reliably detect presence when chilling on the sofa or working quietly at the desk. A millimeter wave sensor solves just this problem. I picked this sensor, which is well supported on ESP Home. You can find the library in the GitHub link below. With this sensor, even the motion called by simple breathing is detected. The cost is much more substantial, about 13 euros, so we're talking almost an order of magnitude more than the infrared sensor. The second issue I had with the previous version was due to the simple fact that, well, in a low light situation, it is hard to see the colors of the different buttons. It is kind of an obvious consideration, but one that I had not considered in this version. I tackled this problem by putting two LEDs on the PCB near the button and a plastic transparent diffuser around the button. In this way, when the LEDs lights up, the plastic ring also lights up of the same color as the button. Now it's really easy to find the right button at night. I also switched to a more powerful ESP32, a bit more expensive but more powerful. Also available with a USB-C powered development board. As with the previous project, I designed the PCB using KiCad. I removed a few components which were not used, and the only thing of note is the sensor uses a 2mm pitch instead of a 2.54 pitch used elsewhere, but otherwise it is a simple PCB that basically routes the pins from the development board. The case also needed to be redesigned. This time particular attention was used in developing PCB also here because now these LEDs will slot into these cavities. So the PCB will slot here, and the plastic insert will go around the buttons themselves. In the front of the base we can find the sensor's slot. The millimeter wave sensor doesn't need to have a line of sight, so it can be hidden from view, which is quite a neat improvement design-wise. On the right we can find the temperature sensor, which a few slots for letting air in, and on the left we can find the slot for the light sensor. This obviously must see the outside world. I printed everything with my Ender 3 Pro. The base required 13 hours and 63 grams of filament, while the lid took about 8 hours and 44 grams of filament. I used dark filament for limiting the bleeding effect on the LED. Regarding the software, I used as a starting point the example provided in the millimeter wave sensor library. I added the components already implemented in the old version of the hub, those being the temperature and humidity sensor and the ambient light sensor. Here we can find the 4 buttons, red, blue, white and green, and here the 4 LED groups. I can go on and install it, manual download, and now it's starting to compile the binary file. This will take a while because it needs to fetch the dependencies needed for the millimeter wave sensor. I prefer to use the legacy format because I prefer to use ESP, the old but trusty ESP flasher. So I can select the board. I plug the board into my PC, and now I can select the board. I can browse to the binary file I just generated, and I can flash it. And now the software is correctly installed on the board. With all the components at hand, it is just a case of populating the PCB according to this schematic. Here is the result. We then insert the buttons. They should obviously be color matching with the LEDs. The ESP32 goes in the back of the board with the USB facing the outside. We then plug in the millimeter wave, temperature and light sensors, and we're ready to slot everything inside the base. We close everything with the lid and finally screw it down with 4 black M3 screws, which go into the brass inserts in the case. Here is the final form of the Omnisensor version 3. So after having plugged in our device, we can go to Settings, Device and Services, ESP Home, and here we will be prompted to configure the device. Yes, we would like to add it, and we will place this device in the living room. So if I can go here on Omnisensor Living version 3 revision 4, I can see the device. For instance, I can turn on the lights. I can maybe turn off these lights so we will be better able to see. We can try to turn on the lights. So blue LED, green, red and white. Oof, I have misplaced the buttons. I put the white one here and the blue one here. I will need to swap it, but well, it is no problem. Down here we can see the buttons. So for instance, the red one, yes, you can see it closed. The green one, the blue one, which has the the wrong buttons, but yeah, and the white one. We can see the readings of the temperature, humidity and ambient lights. and also the millimeter wave sensor that can clearly see my presence since it is in front of me. And now we can use all of these information in order to develop powerful automations. For instance, I can use the presence sensor for lighting up this LED when the ambient light is low enough. This will allow me to see the buttons at night, for instance. We can, of course, program the buttons for executing different automations, and we have many possibilities in order to take full advantage of this hub. This solid improvement on a already satisfying project renders this hub quite more usable, since it can now accurately detect the presence and it can be more easily interacted with at night. All in all, the price has gone quite a bit due to the introduction of the millimeter wave sensor. In my opinion, it is worth the extra money, since it performs radically better than the infrared sensor, and it can be used in a kitchen or in a living room without fear of quite annoying false negatives. I hope you enjoyed this video. You can find below all the resources for building this hub yourself. Until next time!